everyone, welcome back to Better Biomed. Today I'm halfway across the country and I am here, you guys at BC Group. And what a fitting place, St. Louis, a city that has done probably more for the development of this country than almost any other city. And when you know it, BC Group is one of those companies that has done more for the development of medical equipment technology and testing than most other companies. And they've been doing it for 40 some years. So folks, why don't you join me over the next couple days as we tour BC Group. Okay guys, here we are at BC Group. It's beautiful, beautiful fall day. We're gonna go ahead and we're gonna take a tour. And I'll tell you, this facility is bigger than you think. There's Mr. Ken.
How you doing, Justin?
A staple of the industry. Wow, guys. Look at this. This is a beautiful lobby.
Welcome to BC Group. I'm Lucio Simone. I'm the engineering manager.
And I'm Tim Welby, Vice President of Sales and Marketing, and welcome to the home of BC Biomedical and Ohmic Instruments product lines.
Yes, excellent. And I see some stuff. Oh my God. Look at all the products. We got a showroom. Look how big the showroom is, first off. And you got a class. Do you guys actually do instructions in there?
We do, yep, we do a lot of training in there for new product and employee onboarding.
Oh, that's so cool. Now, are these guys in current production?
These are not. These are classic products that these are from way back in the day. We've taken these older designs and improved them with new technologies and new instrumentation. But that's where it all started.
Oh, yes. There's some history here, folks. There's some history here. So BC has been a staple of the industry for 40 some years, 40 years?
That's correct.
Wow. And many of these products, as you're going to see as we go through, you're going to see that some of the designs don't look like they've changed that much, but that's for a reason. In fact, you'll probably see some of that in just a moment. All the ohmic scales, these are the watt meters. Very cool. And if you can imagine how complex it is to develop all these different product lines.
Our goal is to make sure that we have a model that's available for your needs rather than upselling you for features that you may not necessarily need.
You know, there's a lot of these models I haven't even seen yet, guys.
Well, and that's why we're here. Let's show it all off.
Holy cow. Wait a minute. I didn't know anything about these.
So those are our pocket-sized patient simulators. Sometimes you just need a quick check of maybe a 3-lead or a 5-lead device. And so those are really convenient and portable.
Okay, now these ones I've used for a long time. And this guy is especially familiar. And it looks like they're a little bit different than what I remember. So what's going on with this? Is this a new model?
That is a new model. So we bought that product line. It was originally manufactured by X-Tech, and they decided to discontinue it. And we didn't want to put all of the people who are using them, we didn't want to put them out of business. So we decided to bring it in-house and redesign it under the BC Biomedical name. Same product, new circuit boards, new design, and now we can continue to manufacture.
Now the SA2000 and 2010 are very familiar. Matter of fact, this one I've used for years. And now we've got the SA26. This one is got the touchscreen, right?
Right. So that's a good example of a product line that was working very well. Everybody was familiar with it, but let's make it new. Let's make it improve. Let's make it easier for the biomeds to use. So then we have a color graphical display, touchscreen.
Wow. I've never seen the handle before.
The rubber boot.
Wait.
That's the protective cover.
Does that rubber boot also fit those ones?
That is correct. It's the we made it universal. It just effective June 1st of this year. Every purchase of a safety analyzer comes with the boot. And if you can notice, there's some cutouts here where there's nothing at that side. Different models have different connection points. So what we did was made it universal, that one size fits all.
That's awesome. Actually, it's a rubbery feel. It's not hard plastic like I imagined.
Yeah.
So it's actually like a silicone or a rubber, and it is a protective boot. That's so cool. And we've got Wade. All right. So that's an analog ESU analyzer.
Believe it or not, an analog scale ESU power meter. So you can measure leakage, you can measure power, you can measure current.
I like how you guys have the adapter so you can do the leakage testing on this one.
That's correct.
That's cool.
That makes sure that you don't get your connections wrong.
Yep. And the 2300, the 2050, 2350, and the tissue response load box. I've never seen that before.
So that's an interesting one. That was a special design for the Force Triad by Medtronic or Covidien. They actually used a light bulb to simulate tissue for the ligature vessel sealing test.
Yeah.
And so what we decided was, rather than just have a light bulb sitting out in the room, why don't we put it in a box and make it adjustable? So there's two different loads in there. One is for simulating a fault during a ligature, and the other is to simulate a sealed vessel. So that box allows you to do that.
So I see here on the 2350, you've got the front display that's static, and now you got the slanted display on the 2400. But what about the insides? Are they the same inside for both those different ones? Is it just the display? What makes the difference between these?
Well, that's a good question. So we can get into details in another video, but the main difference here is we took the classical wire wound, the non-inductive wire wound loads.
Yeah.
In the 2400, that was the original design. And we thought there's got to be a better way to make this lighter, to make this more portable for the Biomed. So we decided to put in surface mount loads. And that's where we went with the 2350, allowing us to go to a lighter, smaller box and still give you the functionality that you need. Not as many loads. The 2400 has 1 ohm resolution. 2350 has 50 ohm resolution. So,
wow. Okay. Well, I'd love to see the inside of that. And I've not seen this guy before either.
So that's a variable load for the defibrillator analyzer. A lot of the OEM testing, the manufacturer of the defibrillator itself, the standard requires them to test at multiple loads. So the typical Biomed doesn't need that unless they're doing troubleshooting or analysis at, trying to figure out what's a problem with the defibrillator.
Oh, that's got an old school ka-chunk type of click.
Well, and the
That's
reason,
very satisfying.
well, imagine 360 joules. You've got a lot of current passing through there. So yeah, it's a big beefy switch.
Nice.
And the advantage that we have over the competitor's product is that when you plug that into the defib analyzer, we can measure that load. And when you're running your test, you don't have to worry about, do I have my load configured correctly? Because it reads the load and it automatically compensates the measurement based on the selected load.
Okay. 2006P analyzer. That looks very familiar. Like a Biotech?
It was initially the Metron model, the DA 2003. And then when that became discontinued, we were buying it from them initially. And then when they discontinued it, we decided to design our own. And we wanted to keep it with a similar look and style, but our own design. And we've been making it that way ever since.
Okay. So I have not had an opportunity to play with this guy yet.
Okay.
I did a video on these, the IPA 3100s. Fantastic little single channel. And this guy here doesn't have to be primed, does it?
There is a prime function just to get fluid passing all the way through the system, and also a drain. But yeah, the main difference with the 3400 here is the multiple channels. And so these are, we can view all the channels at once. We can have 4 different infusion pumps being tested at the same time. And then these are also easily removable for calibration or maintenance. That way, if you have one channel that's due for calibration You can just unscrew that from underneath
Right.
and pull it out and send it in for cal. And you can still be testing with your other channels.
Right. Each of those modules work independent of each other. And so if you take one of the modules out, the remaining modules are still functional.
And they're calibrated independently.
And they're
right?
calibrated independently.
Wow. Okay. So you don't have to send the whole unit in for a calibration.
That is correct.
Correct. All of the calibration is stored by channel
That's very cool.
in the module itself.
Okay.
So that's
Go to simulator.
it's another one of our newer products, the FSX 1101. That's our digital pulse oximeter.
Yep.
So very, again, easy to use with a color touchscreen. There's only one button to turn it on, and then everything's done through the graphical menus.
Oh. Pretty.
Very easy to change your desired.
This is manual mode. That means it's also got an automatic mode?
It does have an automatic mode, and you can synchronize it with your patient simulator or NIBP. That way, your non-invasive blood pressure plus your SpO2, respiration, IBP, all of that is synchronized to create a true signal to the monitor.
Okay. Oh, look at all these. Now these, what are these for?
So these are for doing TEE ultrasound transducer testing, and not just for TEEs. That's just the most common type. But the ultrasound transducers, they used to be tested every year, just to make sure that they're safe and not leaking. But around 2015 or so, there was a mandate that came out that said they need to be tested in between each use. And so that really grew the need for this particular product line. And what we found was that initially there was one adapter. This one adapter fits all was the initial mentality. And that's the rubber, the conductive rubber pad. And so you can imagine trying to plug in, if you have a connector on your ultrasound probe that looks like this, well, that's not necessarily going to be compatible with that rubber pad.
Right, because they're all going to be at different heights and widths and thicknesses.
Exactly. So what we decided was, the manufacturer already has a connector picked out for their ultrasound machine.
Yeah.
So why don't we use that connector in our design and make our adapters using that same connector? So this way we get the exact same connector that the OEM is using.
Interesting. So
now it leads to a lot of adapters. So
for what guys don't know is what you're doing is you're testing from a known point internal oscilloscope to an external point, and they're looking for leakage between those two, which there should never be because it should be isolated. However, if there's any nicks or anything, then that will pick up the electrical current. It'll transmit from one to the other because it will find any weakness in the insulation or the sheathing. And since the distal end down here moves around, that flexibility, the patient often bites down on it and stuff. And because of that, it creates damages. Interesting. Okay.
Now the benefit of that also that we provide in this product line is that we have a meter mode. So when using the meter mode, we can just apply, and we actually run as a multimeter.
Okay.
So essentially you can take your transducer, if you failed the test, you can take the transducer and dip it into the water, and at some point you can find when the current peaks.
That's cool.
So now, rather than just finding bad probes,
Right.
you can find where it's bad and you can repair it rather than waiting until it's a catastrophic failure and having to replace it. So it saves a lot of money.
Wow. So guys, that is quite the product line, man. So, and this is only for the BC Biomedical. You're going to see that they produce many more things than just what you're seeing here. And we're going to go and see how that happens right now. Let's do it. Ooh, I like how everybody's got the badge that it takes to get it. This facility is gorgeous, and it's actually very high-tech, high security. So in order to go into any of the secure areas, you have a badge.
So now we're headed to the sales and marketing area where our inside sales and marketing coordinator are housed, and they take care of all of our customer calls. They do our consultative sales with our consultative conversations with the customer to make sure that they are purchasing exactly what they need and making sure it meets the needs as they, not only maybe for today, but as they grow moving forward also.
Very cool. So if you call the BC group, you're going to talk to one of these guys.
Yep. So when you call BC Group, we don't have, during normal business hours, we do not have an auto attendant. We actually have a live person that answers the phone, and then we'll direct that call to the necessary person that you're looking for.
So you're going to talk to a real human.
That's right.
Hold on, guys.
And the benefit that you have is you've got service, you've got tech support, you've got engineering, all available through the same phone call.
Guys, so these guys they've been in the business for so long that they curate. You're going to see throughout this tour, they also have a lot of vintage technology, medical tech and medical testing technology. And they have a lot of it in beautiful condition, by the way. So you'll see it as we go throughout the tour. That's fascinating. You guys know I'm a nerd for vintage electronics, especially medical testing. Let's do it. And by the way, the offices here are gorgeous. They're large. They're gorgeous. This is probably one of the biggest office spaces I've seen in a while. I mean, come on, guys. Holy cow. It's kind of cool because everybody has a little office space.
And now we're approaching our front office area where the front office staff who handles purchasing, billing, etc. They're all housed in these cubicles here, and they keep us afloat.
Okay. Sorry, we're going to try and be reasonably quiet so we don't interrupt business because there are meetings and stuff going on. There's a lot more going on in this building than what you would think. This is so insanely gorgeous. I had to. What a beautiful centerpiece.
Why just have a humidifier when we can have a whole globe?
Yeah, no kidding. That is definitely a humidifier. And it felt warm too. So again, there's a bunch of people in cubicles and stuff. We're gonna try not disturb anybody too much.
So one theme that you'll see a lot here is that we try and do as much in-house as possible, even to the point of we have our own in-house publication station here where we print our own user manuals. We'll do the trimming, the binding, all of that's done here in-house.
Wow. I think I've seen like 3 or 4 conference rooms now. That's wild. Okay, and these are some big, beautiful offices as well. We're not going to disturb anybody. That's the man and the legend right there. I'm not going to disturb him though. Okay. Ooh, we're going in behind the scenes, folks. Behind the scenes, y'all.
Now we'll head into our engineering department. This is where we make all the magic happen. We take all the napkins from all of your ideas and the sales guys, and we turn them into actual products. So we split our time between designing new products, maintaining existing products, making test fixtures, automated test stations, the whole 9 yards. So the benefit of having all of that in-house is that when you see something that you need a new feature, or you have a problem with a product, or even when a component goes obsolete, we can redesign our products here. We're not dependent on anyone else. We can redesign them and make sure that your products can still come and you can still do your job.
You see Mr. Lucio's office. Anybody that's got meters at their desk is a cool dude. And airplanes and meters.
So we also have in-house, we're doing new product development. We're doing mobile device. This is where
So you guys do software?
So we do software. This is where we're developing our BC Biomedical app, where you can do all of your Bluetooth testing and automating your test sequences and test data. Here we're designing a new product. We won't give too many details. We'll leave a little mystery to it there, but this is how we start. We have a circuit board, we lay it out, we have prototype boards, we hook it up to the oscilloscope and make sure that everything's working before we ever put it in a box.
Everybody's focused.
And then we've got, this is our web development here where we're integrating with test equipment to gather test records and integrate those test records into your CMMS system to where we can open a work order, we can fill it with test data, we can fill it with the number of hours it was taken to run the test, we can do the billing, and then we can assign the pass-fail status and close that work order all right through our web interface. You might see a couple of things covered up here today, as we have some things that are under NDA with other customers, so we can't show everything. But this is a big part of what we're doing is developing new products. We're focusing on the user experience. How do we make it easier to use? How do we keep you from having to read a 150-page manual just to perform a simple function test? So we're trying to focus on graphical user interface, on easier to understand controls and setup.
Good stuff. Man, the overall age group of your engineers is younger than me, and I feel old now.
Well, and it's interesting. What that brings is we get our younger guys are eager. They want to learn. They want to show what they know. And so we can combine that with the experience that we have. I've been here for 30 years. We can combine the youth and the new ideas that they can bring to us, along with the experience that we have in making the products, and we can bring that to you and give you the best product that you can have.
That's so cool, guys. There's like a 4th or 5th conference room now.
There's always a meeting.
Oh yeah, I could imagine, because you got to coordinate product development, sales, R&D.
And then in here, this is our little playroom for engineering.
Ooh, we got drapes.
So this is where this is our temperature chamber here. So anybody who's ever worked with a pressure sensor will know that, your pressure sensor is temperature dependent. So we'll do pressure calibration with our Mensor, and then we'll do temperature calibration with the chamber here. And that allows us to do compensation for temperature to make sure that your pressure meter is going to be accurate regardless of what temperature it's running at.
Wow. So it keeps a table of all its known temperatures. So the device itself knows how warm or cold it is.
It measures the ambient temperature.
Okay.
That's correct.
That's crazy. That's stuff I never would have expected. What's going on over there?
So here is an example of EMC testing. So, when you apply the CE mark to a product, you're basically vouching that you have done electromagnetic compatibility, meaning that you are not going to be transmitting any interfering signals that might affect other equipment in the hospital or anywhere else.
Right. So me just walking up here probably with my telephone and these wireless microphones are going to trigger.
Yep, that's where you're seeing a spike in there. Yep. So
I could definitely see that. All right.
Yep. So we'll do testing in-house. Now, this is definitely not laboratory grade equipment, but we can do pre-testing. And again, the whole idea is bring everything in-house. Why spend all that money and expense to go to a test lab just to fail on your first pass? Then we have to pass that expense on to you guys. So when we do our initial testing here, we know whether or not it's going to pass before we go to the test lab.
So do you guys prototype with 3D printers?
We do. We do a lot of prototyping. So what we'll do is we'll print examples of our circuit boards. So you can design it all in CAD. You can look at it on the computer screen, but it's just not the same as holding it in your hands. So our printing capabilities allow us to print our circuit boards, print our enclosures. Again, you're doing a mold for a custom enclosure. That's going to be $20,000, $30,000, right? So you don't want to do experimentation with that. So what we'll do is we'll print everything, make sure that it's going to fit, and then we'll go to print and actually get a mold made.
I see a whole lot of ESUs. What is going on with all the ESUs? That's so cool.
So yeah, we do a lot of ESU testing and evaluation. So we first started with Covidian with the Force FX, and they had the Fluke 8920 that went obsolete. And so we designed the 2050 to be a replacement for that Fluke 8920. And so as we went on, then they wanted integrated loads, right? Then we want to automate it. And so it's just one step after another. And then they came out with the FT10. Then along those lines, some of the new device manufacturers, such as Olympus, they came out with these pulsed waveforms that were unlike anything we had seen before. They typically, like for the ConMed 5000, the pulsed waveform was either on or off. And so the ESU 2050P, the ESU 2400, those could read those signals no problem.
Now these are really high frequency, aren't they?
Well, the solder goes up to 4 megahertz. Okay. And so, yeah, that's a whole nother ball game there. So, but these pulsed waveforms, the 2400 couldn't measure that. And the 2050P, because there were multiple amplitudes, it wasn't just on or off. And that's where we developed the 2400H, that we can see the different levels of, it may have one section of the output that's 50 milliamps, another section that's 100 milliamps. We can separate those and measure those independently and give you the timing and the power and the milliamps in each section.
Because
So
I know
truly
some of
unique.
the older ESU analyzers, they don't like some of the newer ESUs.
That's correct.
Okay. Wow. That's interesting. Okay. Well, here's a question for you. So let's say I have an old ESU analyzer.
Mhm.
Do you guys offer a trade-in or something on the old ESU analyzers in order to get the high frequency capabilities? What?
You don't have to trade it in. We offer an upgrade package. And so what that gives you is you can send it in. We'll replace the analog circuitry and give you the advanced 2400H without having to buy a whole new unit.
Wow.
We'll recalibrate it. We'll bring it up to speed and make sure it's all working properly and send it back.
That's kind of cool.
Yeah. So that's kind of our theme as well. You know, when we come out with a new feature, a new function, we try to make sure that you don't have to go out and buy a whole new piece of equipment. We give you that upgraded option in the product line.
Very cool. Definitely a rarity. Now we're getting into some of the cool stuff. We'll have to, holy cow, it's a big room. All right, we'll have to, I'll try, guys, to get you the best camera angles I can. I'm sorry about that. We have a lot of stuff going on, and we're gonna do a subsequent video on the manufacturing because there's so much going on. And I'm gonna slowly pan. And you guys can see we have a wall of components over here. And we have various levels of quality assurance and component fixturing. And wow, you guys, it's so quiet in here. It's like whisper quiet. You would think in a manufacturing environment, it would be incredibly loud.
Not here.
Even the ambient noise would just be loud. That's very quiet.
Yeah, and the pick and place line is even running in the background.
I think
there.
that's the one thing I was kind of worried about is the audio quality. Like as we get into the production environment, this is cool.
Yeah,
And one thing you'll see
noisy.
is another common theme that we have is we don't obsolete product. So even this is where we, finish up circuit boards and do manual operations on circuit boards. Even after they're done on the automated line, they still have to be finished off manually. And we even make products that we've been making since the 80s. So
Wow.
some of those have to be made by hand. They can't go on the surface mount line.
Let's see if I can give you guys a shot down here.
In this area, we have all of our subassembly production. So we do batches of cable assemblies. We do mechanical subassemblies. All of that's done in this area here.
What is this cool piece of technology?
So this is our automatic optical inspection machine, AOI. So that will bring in a circuit board that's just been assembled.
Yeah.
And it will take a picture of every single component, every solder joint, and it will make sure that it's in the correct orientation. It has enough solder on it. It's not rotated or missing or solder bridge, all automatically.
Wow, and you guys got multiples of those devices, right? Because that I'm assuming is the same thing that we have here.
This here is the product line that actually puts the parts on the circuit boards. Okay. So raw circuit boards come in on this side and completed circuit boards come out on the other side. So if we go around to the other side, we'll probably see.
We'll get a better video of this in our subsequent. We'll go through all the details of the processes. So we've got machines, and what they do is they take little components, they stick them on the board. I'll get you guys video of that. We'll detail manufacturing later because there's so many details of manufacturing that you guys should know about, especially since we're doing it here in the USA, which is wild. So you got more pick and place, and that conveyor right there is what actually melts the solder. And then we got other components down there that they're placing. Very cool. Are these test benches for afterwards?
Right. So once the circuit boards are fully assembled and been through optical inspection, then we come over here where the sub-assemblies and the cable assemblies that were put together, these come together with the circuit boards, and the technicians will do the calibrations, the turning the pots, calibrating all of the circuits, making sure that everything's functioning properly, and the final assembly is all done here.
Sorry guys if I got a little bit of the shaky cam going. I'm doing my absolute best, and holy cow, look at all the products over here.
And then over here, you're looking at some products that have been sold. They're getting ready to be packaged and shipped to the customer. We have the ESU 2350.
Look at all these. You got like an army of these. Oh, so these are the
ultrasound leakage testers, yes.
Leakage testers that we seen in the product showroom. Wow, you guys do sell a lot of those. Okay.
It's a popular item.
Very cool. Oh my God. You know, here's the crazy thing. When I think that this was probably going to be about all that you would expect, that's when we go into another room and another room, and we're seeing a whole lot of stuff. So over there is the service department. I'll get a whole separate video of all that for you guys, because these guys service equipment, and I bet you didn't know that. And they have field service technicians. Bet you didn't know that. And we also have a line of CNC machines. Oh my gosh. Are we allowed to go in that room?
We sure can.
Okay.
A lot of the parts that we use are, they're custom designed. You're not going to find it off the shelf, like our ECG snaps or the enclosures, even machining the holes in the enclosures. So that's where this assembly, these machines come in handy. We can even see some ECG posts here in the window, but this is where we do all of our machining in-house. This is, again, the same concept. If we can do it in-house, we're not reliant on anyone else's design schedule or manufacturing schedule. We can change our schedule to meet the needs that you have.
Really cool. Holy cow. And I can see, well, these are the all automated CNCs.
That's correct.
So I can see that you got a waste bucket, and you've got, it drops the parts out when they're completed.
Yep, 5-axis. We got the 5-axis mill there. We've got a dual action lathe, and then we got a Swiss lathe as well.
Okay, very cool. Well, let's do it. Let's take a look. See, now I thought this was the edge of the building, and
we just keep going.
Well, this looks like material handling. Okay, now these are definitely, they're not incubator cabinets, they're drying cabinets?
Those are dry boxes, yep. So all of the components that go on the surface mount components that go on the circuit boards, many of them have moisture sensitivity, meaning that if they're allowed to soak up humidity, when you run them through the oven, they'll actually internally damage themselves, and then they don't work when you run through production. So most of the parts have a requirement for maintaining the humidity at a very low point, and that's where we do our storage.
I see a paint booth.
Paint booth, a lot of prototyping that we do, so we'll do painting in there. This here is an automated test stations for safety analyzer and ESU.
So that is not a 3D printer, folks.
It was. We bought it as a 3D printer. We gutted it.
This does not look like a 3D printer that I know of. No, that's a camera for sure.
This is another example of what we do in engineering.
Oh, these are so cool. That's really heavy. Are there magnets in it?
Right.
Look at this.
So we can enter the serial number for our product.
Oh, look at that. It shows you a representation of what the camera's seeing.
Right.
And is it looking for the lights?
It's looking for all the lights. It knows whether the polarity is forward or reversed, whether the hot and neutral are on or off.
Very cool. So depending on what you're testing, you put a different blank down over the surface, and that makes sure that only certain areas have perforations. So when a mode on the electrical safety analyzer is activated, which is this a finger?
That is a finger. So we're going to go ahead and start it off here.
Okay. So the finger is going to enter a mode, and then it's going to test. And the camera is going to look to verify that the mode is activated using software.
So now it's connecting the ECG posts. It's going to get to the right mode.
Oh, that's cool.
So this is a way that we can automate our routine calibrations of safety analyzers.
Right.
And then we can pass that savings on to you, because rather than having a person sitting here pushing these buttons, we can just have the machine do it over and over and over again. It gives us repeatability. It gives us, you make sure you don't fat finger any numbers that you're typing in.
Yeah. Okay. And another interesting thing is, especially with the membrane buttons, kind of like that, is if it doesn't activate, then we as humans, we would tend to just hit it harder. And but the machine, if it doesn't activate, then now you know that there's a problem with the membrane button, something that a human might not actually be able to detect, because we would just naturally push it harder. So you have a pre-configured X and Y axis, and then it presses it. That's very cool.
We can see here that it's detecting the readings of the unit. That's the optical character recognition for all of the indicators.
Look at that. You're right. Look at that. So it verifies that the correct mode is active.
So even a device like the safety analyzer that doesn't have an RS-232, it doesn't have Bluetooth, we can still automate that process.
Yeah, because light is the only way that you'd communicate what mode it's in.
Right. We read the LEDs.
That's so cool. So they're in-house engineers. They design solutions like this to actually decrease their costs and increase their repeatability, which I haven't asked yet, but you guys are ISO certified. What ISOs do you guys have?
So we have 9001 is our base quality system.
Right.
And then we also have 13485.
Medical device manufacturing.
Medical device manufacturer and good manufacturing processes. So that brings up a whole level of documentation, a quality system. We have a whole quality department. They make sure that, they make sure that we're following the procedures. We have written procedures for everything. Everything's documented. And we also get inspections and audits every year for 1345. And then also the FDA. They like to just show up at random and say, hey, we need to see all the records for your medical devices.
That's wild. And what's even crazier is, any biomed that goes into like hospitals looking at calibration tags and stuff, right? And even these cabinets, which I wouldn't naturally think has a real calibration, it has a calibration.
It's got a measurement, it's got a cal.
Wow, that's crazy.
Because how do you know if that's right?
Well, okay, that's good. So this is where you test devices? I see a bench over there.
Right. Again, this is routine calibrations for ESUs.
Okay.
So we have, again, by bringing in automation, we can bring that repeatability and that consistency to the testing procedure. The tech doesn't need to remember the procedure. They don't need to open a book or find a service manual. They plug the device into the automated bench. The computer runs the test. In this case, we're measuring all the resistances of the ESUs. And if anybody has done that manually, there's a lot. So there's a lot of measurements to take. And so this automates that and makes it much easier and consistent.
So what's crazy is you might see boxes like this kind of floating around BC, and it looks like it's a final product because technically it is, but a lot of these solutions are not open on the market. BC, when they see a problem with their own processes, they develop a final product for their own processes. And now you have up here a meter that's calibrated that runs the breakout box, and that breakout box is actually really sweet. So depending on what model you've got plugged in, that's got the breakout for it. That's very cool. Okay, and
And then this rig over here, this rig is the reason we don't do on-sites for ESUs. So all of that equipment is required to do a true calibration on an ESU, 2050, 2400, 2300. So there's thermal voltage converters in there. There's switch boxes, signal generator, calibrated DC source, multiple multimeters.
Yeah.
And this system allows us to do that calibration autonomously. We can sweep all of the frequencies across the operating range. We can sweep the amplitudes, and that's just something you really can't do in the field.
You know, as I was just saying, like they come up with their own processes. And a lot of places, if they had to make a one-off, they would just make a one-off product. But here you can see it, they actually make something that looks like it's fully productive, a production-ready device, even though it's for their own uses and it's for testing electrical safety analyzers. That looks so cool, guys. I really like how you guys have got it mastered, coming down with an enclosure. You make your own PCBs.
That's right.
Even for something as small as a breakout, you guys come up with a final product as a solution, even though it might never be sold to the public. You still make it look nice and official, even for in-house use. That's so cool.
And again, that's our benefit of having engineering in-house, all under one roof.
Heck yeah, and manufacturing.
And manufacturing.
That's crazy. Wow. So we will cover these areas here in a subsequent video, guys. We have a warehouse over here. We'll talk about that in a whole nother video because holy cow, there's some cool stuff over there. And there's some cool stuff over here. Heck yeah. All right, guys. Wow. Tomorrow on day 2, we're going to do a manufacturing video where we'll actually cover in detail what these machines are and the parts that they're making. So today I just want to cover the fact that, oh, look at that tool changer. Yes. That's a thing of beauty. That is so cool. So they make a lot of their own products, and these aren't necessarily BC Biomedical. So you guys got to remember that they do. It's just switching tools right there.
Yeah, that machine in particular is making a spray gun for silicon wafer processing.
Wow.
So all kinds of applications. We do plastic parts, we do metal parts. All this stuff you're not going to find off the shelf. So we have the engineering team to be able to design the part.
So even if there's a device or a part that is no longer made,
correct,
you guys come up with a solution.
That's right.
That's wild.
So if somebody did make it and they decide not to make it anymore, then we can pick it up and start making it ourselves.
So that's an automatic bar feeder. That's cool.
Yeah, and this is a prime example of standoffs. You know, even for making all the different products that we make, we have different sizes of standoffs. And so you can see some of the bar that we use. We start with a raw bar, and we just machine the exact size that we need, the right threads, 632, 432.
That's amazing because you guys have non-standard devices. Like you have so many different models that you would have to have different lengths of the standoffs to hold the boards between each other. Right. That's so cool.
We probably had 100 different sizes of standoffs.
Yeah.
And from an inventory perspective and purchasing, it's a nightmare. But when you start machining them yourselves, you just make whatever you need.
Oops, sorry for the shaky video, guys. In a manufacturing environment like this, you have to be really careful that you're not backing into something because there's things that move and things that will kill you in these rooms. So I'm paying more attention to my surroundings than I am the camera, so I apologize, folks.
So this one here is our Swiss lathe.
Yeah.
I mentioned making ECG posts. So this is a prime example. Here's an enclosure. We would buy this part blank without any holes. The machines, the mills back there will make all of the holes in the part. And then this Swiss lathe will just crank out as many of these parts as we want. These are the ECG posts, the back of the ECG posts that we use for our safety analyzers and NIBP, DFib. So
That's the finish quality on those is fantastic. Fantastic. Very cool. Oh, and now we're getting into the manual machining area.
Right? This is where it all started. So a lot of what we do is prototyping. So it's great when you want to make 10,000 parts, but what about when you're making your first one? How do you know that it's the right size, the right shape? How is it going to fit together? So we'll do prototyping back here. We've got horizontal bandsaws, vertical bandsaws. We've got routers, a manual mill.
This Enco over here is a piece of history.
Yep, I used that, 30 years ago when I was first starting. We would make test fixtures, and
That's in fantastic quality too.
it runs like a champ.
Wow. I know a lot of those Bridgeports and stuff, they get kind of clapped out, and you can actually see on the ways that they're getting wore out. That looks beautiful. Got an army of drill presses. Monster bandsaw. Holy
Yeah,
cow.
that cuts through aluminum just as well as plastic, just like it's butter.
You got a computed chop saw, or is that a grinder?
Correct. Yep, that's a chop saw for aluminum bar stock, and
All right. Very cool.
yep. And then we still have remnants here. This is from our old semiconductor days. That simulates a deionized cleaning system and aspirators where they need to mix deionized water with acid as they're draining a tank. So we can simulate that aspiration and mixing ratio 10-to-1 or 2-to-1.
Wow. Again, guys, sorry about the shaky camera. If you can see, there's sharp objects that are coming out from all sorts of different angles, and I've got to look around me as I'm walking through the camera. Holy cow. Okay, so this is obviously materials handling.
Materials, right?
Yeah.
So
But those are all enclosures, aren't they?
those are all enclosures, again, from our semiconductor manufacturing parts. So temperature controllers, rinsing controllers, that sort of thing. We designed those back in the 80s, and we keep on making them. So they still work.
Pan here. I'm only in the back corner of this warehouse, so to show you guys kind of what we're dealing with. This is the quietest warehouse. All right, wow, okay. So the warehouse is quite large, and I'm not gonna take you guys down every single aisle, but look at this, they have an army of devices that are ready for final production.
So what you'll see is some of the stuff we can't make in-house. Some of these enclosures we have to get from outside sources. So when that happens, we like to buy a year at a time, because as we learned through COVID, some of those lead times got up in the 25, 30, 40 week time frames. Yeah. And that just doesn't work for us. So we'll buy a year's worth of parts at a time to make sure that we have uninterrupted.
So look at all the OHAS scales. OHAS is one of the finest names in the scales. And there's so many OHAS scales. You guys saw a lot of those?
Absolutely.
Okay.
UPMs.
Yeah, I mean, look all the way down. And I'm noticing over here, sorry guys for the sweep. Look at all the scales. These guys just go off on the scales. Man, that's because the OHAS is a vital part to one of you guys.
The UPMs, the power meter, ultrasound power meter.
Yep. So you can see they have all sorts of components, and we'll go into why they are components and not final production, and we'll talk about that in another video, because this way here they can make sure it's kind of like when you eat cereal. You know, you want the cereal that's fresh, not the box that's been open for 2 weeks. It's the same thing with medical equipment, because it's calibrated. So we'll talk about that later. Holy cow, look at all the parts. Every time here, I'm gonna have to switch to a wider camera angle. There we go. Oh my gosh. All right, sorry about that, guys. Let's see, now we can get you a view of this warehouse. It's massive. And this is only one of the warehouses. You guys can see that we have a lot of parts.
A lot of UPM enclosures and
Yeah.
lids. Again, buying in bulk.
Man, the finish quality on those looks beautiful.
Yeah, it's a great powder coat on there.
Holy cow. And look over here again. And all the hard cases. Man, I love these hard cases, by the way.
It's great for portability.
Yeah, those things. As a field tech, those were really nice. Holy cow.
And then we have our smaller assemblies, NIBPs, patient sims, pressure meters, all of that over here.
Wow. And more scales. Guys, you think I was kidding about the scales? Look at
They just keep going.
Yeah. Holy cow. That's wild. And I see you guys got a lot of ultrasound probes and stuff too.
Yeah, so the idea is if we're going to design an adapter, this is the PA12, let's actually get the transducer that is going to be plugged into it. And we don't just, design the adapter and throw it out on the market. We actually get the product that's going to be used, have it in-house, do our testing, and make sure that everything's working properly. It's another common theme that we have in our product design is, making sure it's going to work in the application where it's used.
Okay. All right. Wow. What a journey, folks. So, everyone, you're going to have to stay tuned. We've got 2 more videos where we're going to go into a lot more detail on this stuff. So we're going to have a video on manufacturing. We'll also have a video on the service side because that's a whole other crazy video, a whole separate section of building we didn't even get to yet. So we'll get into some details on manufacturing. It's just one of those things, guys. I'm trying to keep this down to about 45 minutes. I don't know if we're going to be able to get there. It's just, we're going to do what we can. All right. So we're going to detail manufacturing in another video and also service. But holy cow, hold on. Just one more thing. One more thing before we go, folks. Look at this. Look at all these ESU analyzers. Oh my goodness. I didn't even see these. That is a whole fleet of them ready to go. So they just got to do final assembly and testing, calibration.
That's right.
And
we install the circuit boards, put the load banks together, and make sure they're calibrated.
Oh, that's so cool.
And that's how we can respond quickly to customer demand and changes in market.
Oh yeah, for sure. Okay, guys. Well, thanks for watching this video. Stay tuned for 2 other videos. They'll be released over the next several days, and I hope you like this tour. It's a very big facility, and sorry for all the camera option issues and whatnot. I mean, obviously, these can be very dangerous environments to walk through. Most places won't even allow you to walk through and videotape a lot of the stuff that they're allowing me to see. So hope you guys appreciate this little behind the scenes view of BC Group. Thanks guys very much for allowing me to be here, and stay tuned. All right.
If you enjoyed this video, don't forget to give it a thumbs up and subscribe for more content. I'd love to hear your thoughts, so drop a comment below with what you'd like to see in future videos.